I shall start the lesson. So first, we'll talk about the classroom rules. So there are practically no rules except for the fact that you're not allowed to disturb the class in any way. Uh, I am here to help. So if you need me to do anything, then just turn on your mic and ask. If you need me to stop the slide, turn on your mic and ask. If you need me to add more memes, then ask. If you do not understand anything, then ask. That's all. Okay, I shall start the lesson. So today we'll cover Unit 4, Atoms and Elements, to revise for Cambridge Checkpoint Year 9. So the contents of the PowerPoint are uh, a definition and summary about atoms, major milestones in the timeline of the atom's discovery, the periodic table, trends in the first group, the seventh and eighth group in the periodic table. So first, what are atoms? Can I get a few ideas? Does anyone want to tell me what their understanding of an is? If not, then I shall call someone. Timing. What do you think an atom? Well, it turns out that timing is eating, so you cannot answer right now. May I ask someone else? Bing Bing then. What do you think an atom is?
An atom is a basic unit of a chemical element. It also means that it is the smallest matter in the universe.
Yes, you are right. Any other ideas about what an atom is? No? Well then, Bing Bing is mostly right. An atom is the smallest unit of ordinary matter that forms a chemical element. Uh, every solid, liquid, or gas and plasma is of atoms. They make up everything. Um, Atoms are extremely small. Each are typically around 100 picometers, pm in short, which are approximately 1 times 10 to the power of minus 12 meters each. So yeah, it's basically very small. And here's some extra information. If you read this comic, you'll understand that if you try to split an atom, there will be a huge explosion capable of destroying somewhere around 2.5 million kilometers squared. Does anyone need please take notes. When you're done, tell me. Right, is everyone finished? Can I okay, then I will proceed to the next slide of the presentation. So, the timeline of the atom, the timeline of the discovery of the atom to be precise. So here is the exact timeline of the atom's scientists who discovered and did research on it. But today we are not going to cover Eugene Goldstein's theory, uh, Robert A. Millikan's theory, and Louise de Broglie's theory, because they're too complex and we do not need to learn theirs yet. So in total, we'll cover 7 theories and discoveries: Democritus, John Dalton's, J.J. Thomson's, Rutherford's, Niels Bohr's, Erwin Schrödinger's, and James Chadwick's. So first, we'll start with Democritus's atomic theory. So here's a picture of Democritus. Very nice smile, thank you. So Democritus theorized that everything is composed of very little building blocks that we now define as atoms, which are physically but geometrically indivisible. Between atoms, there lies empty space. In fact, 99.99999999999% empty space. So yeah, we're physical, but we're not actually physical. Atoms are indestructible, just like this Nokia 3310 phone, and they have always been and will always be in motion. And that there are an infinite number of atoms and kinds of atoms. Does anyone need me to stop to take notes?
Yes, please.
Okay, I'll give you another 2 minutes to take note of this. Right, are we all finished? Right, then now I shall proceed to the next slide of the presentation. So next we'll cover John Dalton's atomic theory. So here's a picture of John Dalton. He looks very handsome. Give him some compliments. Okay, so his theory is practically the proof of Democritus' theory, which happened approximately 2,300 years ago. So he proposed that all matter was composed of atoms. Um, they're indivisible and indestructible, very small building blocks. While all atoms of an element were identical, different elements had atoms of differing sizes and mass. So Dalton's atomic theory also stated that all compounds were composed of combinations of these atoms in defined ratios. And lastly, Dalton also postulated that chemical reactions resulted in the rearrangement of the reacting atoms. I'll stop for 1 to 2 minutes for you guys to take notes. Right, are you all done? Are you all done? So here's a, he discovered using experiments with his cathode ray tubes that atoms contain negatively charged subatomic particles, or now we call them electrons. So he proposed that the atom was a sphere, but the positive and negative charges were embedded within it. So here's a picture of his atomic model. So as you all can see here, there's a circle, and within its range there are positively charged matter and some electron particles scattered around. Okay, now I shall give time to take notes. For more efficient studying and comprehension, I'd suggest you draw your own style of his atomic model so you can understand it better in your own way. Right, are we all done? Okay, then if you all finish the note taking, then I shall show you the his atomic model. You should draw it in your own style, as I said, to understand it better in your own way. Does anyone need more time to draw their models? Okay, then I shall proceed. Nextly, the person who has given the most contribution to the discovery of the atom, Sir Ernest Rutherford. So yeah, he looks very handsome in this Nazi helmet. Do you guys think? So his famous experiment that he used to discover the nucleus of the atom. So he used an alpha particle emitter to shoot a straight ray of alpha particle through a very thin gold foil. It's less than 1 millimeter in depth. So if the atom was totally electrons or empty space, then the ray should have gone all through. But then he discovered that some of the particles are deflected back into a slit. So he thought, there should be something in the middle of the atom. So yeah, that was how he discovered the nucleus of the atom, which contains protons and neutrons. You can write this down as notes in your own way, but the key points are that Ernest Rutherford was the one who discovered the nucleus of the atom. Even though it's hard, I suggest you draw this experiment into your notebooks in your own way so you can understand it better. I'll proceed in approximately 2 minutes. Okay, you all done with your notes or your drawing? All right, then I shall proceed. So nextly, um, so we will summarize all the atomic models that these guys have discovered and thought of. So first, it was John Dalton's. Yeah, it was John Dalton's model of the atom, and then Rutherford, he uh, he after his experiment, he drew up the first accurate model of the atom. You can draw this in if you want to. Um, yeah, and uh, if you somehow can't read or don't know, then Rutherford's model consisted of a nucleus with a somewhat hexagonal set of orbits for the electrons to revolve around. If you're done with your Rutherford model drawing, then I'll proceed to the next model. So, okay, Niels Bohr, um, Rutherford's late colleague, so he took Rutherford's model a bit further, and he came up with this model, the one that we are currently looking at and using. So, the nucleus is in directly in the middle of the atom with several orbits, or now we call it the atomic shells around it, with various numbers of electron subatomic particles revolving around it. So for any one of you who want to draw this model into their notebooks, I'll give you a bit of time. Drawing this model should be quick, should it? Okay, I assume that you guys have finished your drawing of the Neo Bohr model, so uh, we'll proceed. So uh, Erwin Rutherford, uh, uh, Erwin Schrödinger, famous for his Schrödinger's cat experiment, which consisted of a cat being half alive, half dead somehow. He did some research and came up with this atomic model. He calculated really carefully and even managed to figure out the rate of the protons or electrons appearing in a place of the atom. But you don't need to draw this model because it's too complex and we are not learning it today. So now, well, so currently we'll stop at the Niels Bohr's model. So uh, we'll continue with the structure of the atom. So uh, the as you all might have known, in an atom, there are usually three subatomic particles: the neutron, which possesses no electrical charge; the proton, which possesses a positive charge; and the electron, which possesses a negative charge. So the uh, the number of protons and electrons in an atom is always equal, and in the nucleus there are the protons and neutrons only. The electrons revolve around it. So in so this is how you read in the periodic table. So as you can see with the carbon particle, element, whatever, here. So the atomic number, which is this number 6 here on top, it shows the number of protons or electrons because since they're equal. In the middle, there's the element symbol. In this case, C for carbon. Down there might be an element name. There might be not. Depends on the periodic table that we're reading. And the atomic mass number, it shows the total number of protons and neutrons. In this case, they calculated it a bit too specific and they got 12.01. But for carbon we usually mention 12 as its mass number. After my long speech on this slide, I presume that none of you need time to take notes, right? Okay, then I shall proceed. So the the electron shells have a rule. I call it the shell rule. This term is created by me. So every atom has electron shells. Uh, it's a bit hard to see because my background is black and these shells are also black. But yeah, so every atom has electron shells, and it's practically the orbits of electrons around the nucleus of the atom. And these shells, they're distinguished by their energy levels. And the outer the shells go, the more energy it bears. Like the one closest to the nucleus bear very little energy, but the outermost shells often bears more energy. I'll give you 1 minute to take notes. Right, are you all done? Right, then I shall continue. So the shell rule is that every first shell, the maximum number of electrons is always 2, no more, no less. The second shell consists of maximum 6 electrons. The third shell max 18 electrons. From the fourth shell to the third outermost shell, 32 electrons are can be held. For the second outermost shell, maximum is 18 electrons again. And for the outermost shell, it depends on the element group. So if an element belongs to group 1, then the outermost shell contains 1 electron. It belongs to group 6, for example, it contains 6 electrons. I'll give you time to draw this table into your notebook. Okay, are we all done? Right, and I shall continue. So these are some examples. This is the a model of the uh, beryllium. Yeah, of the beryllium atom. So huh. so as you can all see, the first shell, it contains 2 electrons, and the outermost shell, since beryllium belongs to group 7, right? Yeah, then it contains 7 shells. And as you can all see, the third shell, it contains 18 electrons, if you all have time to count. And it appears that I have somehow made a mistake. The second shell, it contains maximum 8 electrons instead of 6. So you can fix your table. So here's another example of a lithium, one of the first atoms that we shall encounter in the periodic table. So its innermost shell contains 2 electrons, and since lithium belongs to group 1, its outermost shell only contains 1 electron. And finally, our last example is oganesson, the heaviest particle that contains most subatomic particles, specifically 118 protons and or electrons. So as you can see, the innermost shell always contains 2 electrons. The second shell contains 8. Then the third shell contains 18. The fourth and fifth shell each contain 32. The second shell, which in this case is a sixth shell, it contains only 18 electrons again. And the outermost shell, since oganessons belong to group 8, the noble gases, um, it contains 8 electrons. then I shall proceed then. So, the periodic table and its groups. So, you might have seen this table very many times. So I'll just cover this quick. So the columns in the table are called groups, uh, and rows in the table are called periods. And there are many types of atoms, all distributed along the periodic table. Group one is the alkali metals. Group two is the alkaline earth metals. There are transition metals and rare earth elements between group two and three. Group three is the uh, other metals. Group four, five, six. They practically they have no names. Group seven, the atoms in here are called halogens, and group eight, the atoms in here are called the noble gases, even though um, from argon to oganesson, the default state of matter for these atoms, they're not even gases. Okay, I shall proceed. So trends in the first group. The reactivity of group 1 elements increases as you go down the group because the atoms become larger, um, and the outer electron becomes further from the nucleus. The force of attraction between nucleus and the outer attraction decreases, and the outer electron is lost more easily because since it's further from the nucleus and there's only one electron, it practically wants to lose that electron to become a perfect particle atom. So yeah, I'll give you a few minutes to take notes. Okay, are you all done? If you are, then I shall proceed. To prove that the reactivity of group 1 elements increases as you go down the group, here's some examples. So this is lithium reacting with water. There are fizzes and bubbles appearing. Next, we have sodium. The reaction, it gets much more intense as we can see sparks and fires starting to appear. Now we go to potassium. So the uh, the reaction is so vigorous that it seems that the potassium piece it seems to explode, and there are like sparks and smoke all around. And what if we go all the way down to group 1, then the final element is francium. And well, no one has did experiments with francium reacting with water, but this is the prediction of what would happen if we put francium into water. An explosion has the power of an atomic bomb. Okay, so trends in group 7 and 8. So we'll cover group 7 first. So the melting points and boiling points of the halogens, which is the group 7's atoms, increase as we go down. This is because if we go down group 7, the molecules become larger, just like group 1. The intermolecular forces become stronger. If you don't understand what I mean by this, then you can look at this table. So here are the three first elements of the halogens. And as you can see, There are states. So the bonds between the particles in the elements at the atoms in chlorine, it's not that tight. So the original state of gas is state of chlorine is gas. But to bromine, the intermolecular bonds, they are stronger. So the default state becomes liquid. And then when we go to iodine, um, it's already solid because the intermolecular bonds are so strong. You don't have to write this table down. I'm just using this as an example. So more energy is needed to overcome these forces due to reason one and reason two. I'll give you time to take notes. All right, are we all done? Okay, let's continue. So the only threat in group number 8, the noble gases. So group 8 elements are also known as the noble gases. These elements already have a perfect valence shell with 8 valence electrons. This leaves the elements non-reactive as they're already stable and they're in a low energy state. Members of the noble gases include helium, neon, argon, xenon, krypton, radon, and oganesson. Well, according to Gavin, our dear science teacher, even if oganesson belongs to 8, um, it can actually read as its atoms are so large, filled with electrons and protons, that the electrons are starting to sort of fall apart, making it an imperfect atom. So here's some pictures of the following atoms. This is neon, as you might have seen some neon lights. Here's krypton, number 36 in the periodic table, and oganesson. That same picture we used in some previous slides. You only need to write with from the beginning to in a low energy state. You don't need to write all of the elements. Right, are you all done? Okay, I'll proceed then. Now the fun part, the quizzes. Prepare for battle. Okay, I'll now share my. So here's the code. Start joining the. And due to the very unspecific and sort of bad quizzes settings, I cannot disable power play as per timings requests in this afternoon. Um, we have 22 class. So where are the last three? Excluding me. Well, I'm just gonna start then. Okay, prepare for battle. And please try your best to do this without reattempts. Why are there so many people who got the question? Who was the first person who proved the theory about atoms wrong? Oh my god. Oh my god, 62% accuracy. Maybe I have made a far too hard quizzes for you people to do. Wow, seems like with his second or third attempt, Ming is brushing up with a 7 streak. DGK, why are you imposting me again, huh? Should I click this X button and remove the fourth player? DGK, why you imposting me using food again and you're brushing up using your 12th trick? Very bad manners, you know. So you guys can leave if you finish the quizzes. DGK, I can still press this X button, you know, and stop using my name to name your quizzes. I swear to God. Oh well, after DGK leaves the quizzes, then I shall delete first. Okay, I'm gonna end the quiz in 2 minutes. Okay, I shall end I shall end the quizzes now. So after many attempts on this very hard quizzes, then our three first players are DGK, Sunwin, and Bing. Congratulations, you people. GG, well played. All right, the lesson ends here. You guys can leave. Bye.